Hello, today we're going to cover gram and mole conversions. So we're going to calculate the number of moles based on a given amount of grams, the number of grams based on a given amount of moles. So far we've done is pretty straightforward. We've talked about if we have, simply 1 mole of something, like 1 mole of magnesium is 24.305 grams of magnesium, because the gram formula mass is 24.305 grams per mole. It's pretty easy to say, okay, what if I had 2 moles? What would I do to that number? Well, it's pretty straightforward. You would just multiply it by 2. So in that case, you get 48.610 grams of magnesium. So this makes sense, but most problems obviously aren't going to be that simple. So if we want to convert from a certain number of moles into grams, we usually have to do a little bit more work than this. So we're going to start with a problem where we want to know how many grams are in 3.66 moles of NaCl. First thing we have to look at is our conversion factor, which in this case is going to be our number of grams per mole. So I've already done my GFM calculation, which gives me 58.443 grams per mole. I already have that down to the number of proper sig figs. Most of the questions we're going to be doing, if you don't round to your sig figs first, the rounding error will come out all right, and you'll end up with the same answer that I get. Because we're kind of limited actually in this problem by the number of sig figs right here. So we could actually, as a conversion factor, either call this 58.443 grams in 1 mole, or 1 mole is 58.443 grams. So we are going to be using conversion factors again, and we're going to be using dimensional analysis. So we're going to start by writing down our desired amount, or I'm sorry, our starting amount, which is our 3.66 moles. Oops, sorry. And our desired ending amount over here is going to come out in grams. So this is a pretty straightforward question that might seem kind of ridiculous to do in dimensional analysis, but when we get to more complicated problems, dimensional analysis will make our lives a lot easier. Since we have moles on the top right here, we want to have moles on the bottom down here. So I'm going to put 1 mole down there, and my conversion factor that puts a mole on the bottom has grams on top, which is perfect. My moles go away, and I end up with my grams right there. So you're going to go ahead and punch into your calculator 3.66 times 58.443 grams. And this should give you, I got 213.90138. I have to round that. I should have 3 significant figures since I had 3 sig figs and 3.66. So I'm going to round that to a nice 214 grams. So because of the number of sig figs I'm limited to from my 3.66, my rounding in my GFM doesn't really make a huge difference with these questions. So, and remember what you're doing here is you're actually multiplying across the top first and then dividing by the bottom. So I ended up really just dividing by 1. So the next problem, we're going to look at magnesium nitrate. Magnesium nitrate gram formula mass, is 148.315 grams per mole, which I can write as either my 1 mole on top or 1 mole on the bottom like I did in the last problem. So I'm just going to jump down to my little picket fence down here. My starting amount is going to be my 5.39 moles of magnesium nitrate from the problem. So I want to determine how many grams from that many moles. I've already got my conversion factor, my GFM. Again, I need moles on the bottom, so I'm going to put my 1 mole down here, and my 148.315 grams are going to go right up here. So what you're actually punching into your calculator is 5.39 times 148.315. I'm technically dividing that by 1. I'm able to have 3 sig figs in my answer, 1, 2, 3. So when I multiply and divide, remember I'm limited to my number of sig figs in the thing with the least sig figs. So this puts me at 799 grams. We could also go from grams into moles. So if you have 12 grams of carbon, since carbon's gram formula mass is approximately 12, you got about a mole of carbon. If you have 24 grams of carbon, that's twice as much. So it's going to be 2 moles of carbon. So in this case, what I was doing here was dividing by my GFM. So Next, I'm going to look at iron oxide. My gram per mass for iron oxide is 159.688 grams per mole, which can be written as that many grams over 1 mole. Or I can have moles on top and do my 159.688 grams on the bottom. So I'm going to jump down to my picket fence. I got my 92.2 grams of iron oxide, carry the iron oxide by doing my gram per mass. Now I want to put this into moles. So I'm going to start by putting my 92.2 as my starting amount. Keep in mind, I want to be ending up over here in moles. Now, because I have grams on top, now I want grams on bottom. So I actually have to put this 159.688 grams on the bottom and 1 mole on top. My grams are going to cancel and go away. So what I'm actually doing mathematically here is I'm punching in 92.2 times 1, or just 92.2, divided by 159.688. So when I do the math for this, I'm going to end up with about 0.577 moles. Again, I'm going to have 3 sig figs since my 92.2 is 1, 2, 3 sig figs. So that again is what's going to be limiting my number of significant figures. I think it can be really important with these. I think it can be really important with these to kind of ask yourself if your answer makes sense. So 92.2 grams is definitely less than a mole. A full mole would be 160 grams almost. So this should be a little bit more than half a mole. This does make sense. So I'm going to do I want to figure out a 291 gram sample of sodium sulfate has how many moles of sodium sulfate. So the first thing I'm going to do is my GFM calculation. So I get my GFM for sodium sulfate, which is 142.042 grams per mole. So this is going to be 291.1 grams. I'm pulling down here. I want grams on the bottom, so 142.04 grams with 1 mole on top. Grams are going to cancel. So again, I'm basically dividing. So I'm doing 291.1 times 1 divided by 142.04. And you should get 2.049. I do have a lot of sig figs here because I have 1, 2, 3, 4 sig figs in my starting number. Again, my GFM could limit me, but never really does. I always have a lot of significant figures in that, so I was able to keep 4 significant figures in my answer. So go ahead and pause the video and try each of these, and I will put up work in just a moment. So these are the answers you should have gotten for each of these: 0.0833 moles, 0.635 moles, 13.0 grams, and 298 grams. If you need to see work, I'm going to go ahead and put your work up for you. In question number 1, our starting amount is our 15.0 grams of glucose. So that's going to dictate that we're going to have 3 sig figs. When I plug in my grams per mole of glucose, so I want grams on the bottom, so I'm going to do 180.158 grams over 1 mole. So what I'm actually doing in my calculator is 15 times 1 divided by 180.158. And then I'm going to round that so that I have my proper number of significant figures, which is 3. Keep in mind that first 0 doesn't count, so those are my 3 sig figs. Sig figs are not going to be important on the Regents, but they are going to be important on my test, so you do need to have your proper number of sig figs. 25.0 for NaOH, our gram formula mass is 39.9971 grams. I want that on the bottom so I can cancel grams out. And my 1 mole is going on top. So remember, in each of these, what I'm really able to do is that. So I'm going to do 25 divided by 39.9971. And then my 25.0 grams has 3 significant figures. So I'm showing 3 significant figures in my answer. I am actually noticing that I think that is in slight error. Let me check my math a little bit. Sorry, that should actually be 0.625, not 35. I apologize for that. So my number of grams in 0.5 moles of lithium fluoride, 0.500 moles. This number is showing 3 sig figs. That 0 to the left of the decimal does not count. Lithium fluoride has a gram per mole mass of 25.939. I do need to have moles on the bottom here. So my actual number of grams, my 25.939, is going to go on the top. Moles are going to go away. So I'm going to do 0.5 times 25.939. This comes out to 25.9695. I need 3 sig figs. Really, the only way to get this is to actually round up to 13.0, and that trailing 0 does count. And last but not least, I've got my 4.00 moles of KCl. My gram per mole mass for KCl is 74.5513. So I have 1 mole on the bottom, 74.5513 grams on top. Moles are going to go ahead and cancel out. Mathematically, I'm doing 4 times 74.5513. Those trailing zeros after the 4 do count since they're after a decimal place, so I do have a total of 3 sig figs. So this rounds nicely to 298 grams.